G'day everyone, my name's Connor McDonald. I'm based in Perth in Australia. Now, full disclosure, I'm not coming to you live. This is pre-recorded, unfortunately just due to a collision in timing. I've got some conference commitments at the same time this thing is on, but of course I didn't want to miss the opportunity to speak to the tuning and enterprise manager style of audience. So in terms of if you want to get in touch with me at any point in time, I love talking technology. The easiest way is you can get to me on Twitter. That's my Twitter handle there. It's an easy way to do it. My DMs are always open. I love talking technology. If you would like to pursue one of the thousands of other social media platforms that are out there nowadays, you can scan that QR code. That'll take you to linktree/Connor. That'll get you all the possible ways you can get in touch with me in terms of LinkedIn, Facebook, Instagram, etc. It's also got things like my GitHub repository on there. And if you like video, you can go to my YouTube channel as well. Lots of things there that you can reach out to me and we can talk about technology and particularly the Oracle database and SQL tuning. Now, given that this is a session on SQL tuning, I'm going to start with perhaps something you were not expecting. And that is, I'm going to open up with this proposition 2. And if you take away anything from this session, this is perhaps the most important thing, which may sound counterintuitive. And that is, if you are actively tuning SQL statements, then I think you're failing. I think you're doing it wrong. Now, I need to be able to justify that. So let me explain why with a real example of why I think the concept of SQL tuning has become perhaps misinterpreted over the last sort of maybe 10 years or so, maybe even longer. I'm going to show you why SQL tuning is still important, but I'm going to try pivot it back to perhaps a more generic meaning. So this is a real example. I was working with a customer. This is actually the last job I had before joining Oracle. Let's simplify their data model down to a very simple 2-table setup. That is, the parent table is a list of customers that are registered for this retailer that sells objects on the internet. Underneath each customer, we have the customer transactions. Every time someone buys something, we put a record in the customer transactions table. Now, when I was working there in the IT department, some business representatives came up to us and they said, we have a report that shows us the last transaction ever conducted by each customer. And there's a very simple problem. When we try run it, it just takes forever. I had to Google what this is actually called. It's called the Infinite Progress Indicator. But this is the report they were trying to get out. And it was coming out, but it was taking way too long. And you can see we've got effectively a customer number down the left and the last time they performed a transaction at the right. As we always do when we get into tuning something that's slow, we jumped in and had a look at the SQL. And this is the SQL that was running. A very simple, for each account number, do a group by and find the highest transaction from this very large customer transactions table. I won't give too much of the information, but it was an online betting site. So you can imagine Australians, they love to gamble. So there were literally billions of rows in this table. And the challenge for us was simple. Make it faster, please. So what are some of the things we tried? Well, the first thing is, when in doubt, we have an expression called Kiwi here down in Southern Hemisphere, kill it with iron. And that is, when in doubt, just throw more firepower at it. So we started running this query in parallel. That did indeed work. It made the query significantly faster. Oracle's very good at exploiting parallelism. But at the same time, when that report was running, when users requested it, we were absolutely melting our storage infrastructure. They didn't really have the I/O bandwidth to support that level of parallelism to get the performance they wanted. So as a result, you end up with this scenario where while the report's running, everything else in the system ran a lot slower. So we had to come up with some other ideas. So we thought, okay, well, why not make an index on that table just on the 2 columns in question, the transaction date and the account number. In that way, we're effectively generating a thin version of the transactions table. Now when we run the query, rather than scanning the entire table, we're scanning effectively a thinner version of that table. We're doing an index fast full scan. That also worked, but as I said, this was a transaction table that had a lot of volume coming in all the time. So every new index had an impact on the OLTP performance. And at certain times before big sporting events, etc., the transaction volume was so high that every single index had an impact on our ability to push through the amount of transaction throughput we required. The next thing we tried was to create a materialized view, which held the result. Obviously, the refreshing of this materialized view took just as long as the report would normally take, but at least that price was being paid once, and then other people would be able to take advantage of it. The issue with that was when people started using the report, they came back to us saying, it doesn't look quite right, because they would have a customer that would perform a transaction and then they would go run the report and that transaction would not appear on the report because the materialized view hadn't been refreshed. We could have added a materialized view log and made the refresh a fast refresh or an on commit refresh, but we're back to that same issue of adding overhead to the basic OLTP performance of the system in order to get this report to run faster. We then explored partitioning. Maybe because this transaction table was so large, what we could do is break it up into smaller chunks, say by month. And then what we could now do is when we ran the report, just go get the last, say, 12 months worth of transaction and use partition elimination to eliminate from consideration a lot of the data in the table. If you look at the explain plan when you're doing SQL tuning, you'll see something like this. The number of partitions start and ending indicate that you've actually only iterating through a small subset of the table as opposed to the whole thing. Now that worked as well, but it actually changed the report function. Because when you do that, obviously, if I'm only looking at the last 12 months, if I don't find any rows for a particular account, all I can really tell the business user is for this particular customer, they must have been at least 12 months ago. Maybe that's a good thing, maybe that's a bad thing. We didn't really know, but partitioning was an option we tried. The other, of course, downside with partitioning is, well, it's a separately licensed option. And it's pretty hard to go to a customer and say, look, we've got a report that doesn't work as well as it used to. And to have that reduced functionality, we need you to pay lots more money. That's a tough sell. To avoid having to face that prospect of trying to sell that to the customer, we thought about utilizing partitioning as well as a facility called partial indexes, where what we could do is have no indexes on the current partition, therefore we would not be impacting the OLTP performance, but we could have indexes on the older partitions. That would then create something like this. For the people that had transactions in the current 12 months, we could grab that data from the most recent partition like we just saw in the previous slides. Then for those people that were missing from that report, we could then do a backwards index tree walk for the older partitions to find out the most recent time they did a transaction, seeing as it had been more than 12 months ago. Now that works as well, but man, we're starting to crank up the complexity here just to solve this problem. And this brings me to the issue I was alluding to at the start of this session, namely, we're IT people, we're IT geeks. We love jumping down into the weeds. The moment says, I've got something slow, and we know it's a piece of SQL that's running slow, boy oh boy are we excited as IT geeks. We're like, fantastic, let's go explore indexing and rewriting the SQL and hints and all sorts of things you've just seen here, all of which are totally valid for some people in some cases. But here's the key point. Before any of that goes on, what you need to do is go back and look at the requirement. Because we went back to the customer after exploring some of these alternatives, none of which seemed particularly palatable. We were going to slow down the performance with indexing, we were going to increase their costs because of partitioning licenses, and we went back and said, look, we're curious, it seems a strange thing as to why would you need the very last transaction for a particular customer? Which sort of what's the business benefit in doing that? And they said, well, what we actually do is have an interest as to what kind of frequency customers are actually utilizing. How often are they coming back and doing something? We just have an interest in what they're doing because, like most websites you've ever been to, I'm sure, if you don't interact with them over a certain amount of time, they start sending you promotional stuff, like, basically teasers to try to get you back online to purchase more stuff from them. Those sort of emails, hey, we haven't seen you for a while, etc., etc. That's actually the requirement. They were using this report, which had previously existed for some reason, to get an idea for which customers were not regularly interacting with the site. Once we knew this, the solution, well, it became obvious to us. We went and had a look at the customer table, and it already had a column on there called modification TS, modification timestamp. It had nothing to do with the business application, business functionality. It was actually there to solve a common issue we have in databases, which is optimistic locking. And that is, if someone brings up customer details on the screen and some other user does the same, we want to make sure that we don't have a lost update problem. And so if you're a developer on the call, you'll be very familiar with the fact that when you query the data back, you pull back the modification timestamp as well, and you store that somewhere. You let your users make some changes on the screen, and when they go to write those rows back, you check to make sure the modification timestamp hasn't been altered by some other session. If it has, you spit out an error saying, yes, okay, your details are now out of date, please refresh the screen and try again, etc. It wasn't necessarily for business functionality, it was for application data integrity. But we went to the customer and said, hey, there's this thing called the modification timestamp. It's not necessarily the last time they did a transaction, but it's the last time someone has done something with this customer account. They may have changed their details, changed their email address, etc. Is that good enough for you? And in this case, the customer said, yeah, that's fine. That's very close enough to what we need. And if you can give it to us rapidly, we'd be even happier. And of course, a query against the customers table, not even touching the transactions table, was virtually instantaneous. We simply changed the report to look something like this. The modification timestamp is a reasonable approximation of the last time someone has used the system as a particular customer. That was it. The lesson here is we got too carried away focusing on the SQL. There's a slow SQL statement. Oh, let's bust a gut trying to solve this particular SQL tuning problem. As I said, if you're tuning SQL, you're doing it wrong. You don't want to be focusing on the SQL. The thing you want to be tuning is something totally different. What you want to be tuning is this. What do I mean by this? Well, we mean that the user, the person's experience. And in the trendy term, we would call it UX nowadays. We never say things like user experience. We say the UX or the CX, the customer experience. But all these things come down to a common mantra. SQL tuning is just a tiny part of the puzzle of tuning what is really important, which is the user experience. Sometimes this does mean tuning SQL. It's a common issue. However, if you jump in straight away to, yes, I need to tune SQL in order to solve user experience problems, you're generally, I think, approaching the problem in the wrong direction. The metaphor I like to think about when it comes to SQL tuning is more that of the hospital emergency room. Now, word of warning here, the next picture is not so nice. This is a picture of when I fell out of a tree when I was trying to prune it some years ago and fell onto this particular fence post. It wasn't a particularly nice experience for me. SQL tuning is what happens when you call the paramedics. It's triage. When the paramedics came along, they weren't trying to cure me or stitch me up, etc., or take x-rays. All they wanted to do was stop the bleeding. Effectively, it's a triage phase. That's what SQL tuning is. You're simply trying to stop the bleeding until you can find a cure at a later point in time. Now, with that in mind, my ranting is over. It's still the case that obviously we need tools and techniques in order to tune SQL. So let's focus on that now. In particular, I want to talk about some of the nice things in 23 AI that help you on your way to tuning SQL. But be aware, you're doing triage here. The long-term cure is focusing purely on the user experience. Let's take a quick look at some of the options you have at your disposal to find problematic SQL. Now, if you're old school like me, you've probably got scripts that point at, say, $SQL. And even if you do have scripts like that, make sure you're trying to do your best to target the area as identified by the customer. In this case, I'd be using module and action just to hone in on particular SQLs that are causing the customer concern. We don't want to just focus on SQLs across the entire database. And typical things we look in SQL are things like high CPU, which maps to buffer gets, high I/O, or maybe high execution counts, which might indicate a problem with, say, the application functionality or design. Whatever the case, if you have queries that go against SQL, I'd recommend you not use that particular performance view. SQL is in fact a pointer directly into the database shared view of the library cache. What that means is that every time you query SQL, the database needs to protect those memory structures to give you a valid result coming out of the database. You protecting those memory structures means other people who are aggressively trying to parse queries and put them into the library cache are going to be blocked because of latching activity. A better option is to look at something called SQL stats. It's a clone of SQL, for lack of a better term. It came in version 10G to address the issue of people aggressively querying SQL. As the documentation states, it is faster, more scalable, and has a greater data retention than the SQL. But because it's a latchless structure, you can go against that memory structure without worrying about harming the rest of the system. Because let's face it, if you're trying to find bad SQL, the last thing you want to be doing is throwing another bad SQL at your database. Enterprise Manager also has some very cool facilities to go finding problematic SQL in your database. Most people typically will start at the Performance Hub, which gives you an overview of the whole database. From there, it's easy to drill into where the most expensive SQLs are. And from there, you can actually drill into the SQL monitoring information about SQL. But don't do that just yet. There's an important step we have to cover yet before you actually dive into things like execution stats and execution plans. Or perhaps the most common facility that people use is the AWR reports coming out of the workload repository. You can do that on the particular database instance that's of concern. AWR is a fantastic repository for finding bad SQLs, especially when customers come to you and they say, oh, last Wednesday I was doing this and it was too slow. The ability to go back in time and look at things that have happened in the past is very useful, and AWR is great at that. Once you've found a SQL statement or SQL statements that are relevant to helping a particular user experience issue, the first thing I would look at doing is what I call find out the real query. To give you an example of what I mean by that, let's look at this simple application query here. Someone's doing select star from looks so innocent. And they run this query and it's slow. It's doing 23,000 consistent gets. When I say we need to know what the real query is, what is looks so innocent? Is it a table? Is it a view? Is it a materialized view? It could be all sorts. Is it a synonym to something across a database link? We need to dig into the actual underlying objects to see what's going on here. And the way you can do that is this utility. In dbms utility, we've got expand SQL text. What it actually does is it tries to work out what the SQL text that would be presented to the optimizer would actually look like. So if I expand looks so innocent, I cheated a bit here. I've built the looks so innocent view as a join between DBA segments and all objects, two of the dictionary views. And rest assured, I know that those two views are themselves built up from multiple views, which are themselves built up from multiple views, etc., in the database. The reason I picked this is because something that looks so innocent, if I actually print out the result from this, I get this. This is the actual query that's running, hence the 23,000 consistent gets. A large query doesn't necessarily mean slow performance, but this is just the first page. This is the next page, this is the next page, this is the next page, 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 the next page. There were 16 more pages of that, which gives you an idea of the complexity that was actually in my looks so innocent view. So it's important that you actually dig down into what the database is actually being presented with so you can get a more accurate idea of the workload that's going to be performed. Once you've done that, before you start thinking about execution plans and indexes and cost-based analysis, etc., have a look at the SQL and does it actually make sense? Is it correct? Let's look at an example. I've got employee and department here, and I'm focused on employees in the sales department and only those departments that are in the North region. Can you spot something that's missing here? Yes, there's no join condition. I forgot to have a join between those two tables. That's obviously going to be a problematic in terms of performance, but obviously in terms of functionality as well. You might be thinking, well, hold on a second. Surely this would be returning wrong results in the application. You'd be surprised how many times I see people solve a missing join with a distinct clause, which seems to solve the issue, but obviously there's going to be performance problems here. Perhaps look at something like this. I'm doing a join here between the employee table and the sales transactions table, and we've got a whole stack of criteria here. I've got the join condition this time on line 5, and I'm looking at sales for the Californian region, someone where their tax amount is greater than 10 or their subsidy is greater than 0. Once again, it looks okay, but what have I done? I've forgotten the way Oracle's going to treat this query in terms of the order of operations. It will process all the ands first, and then at the very end simply say, or subsidy greater than 0. I'm going to get all the rows with a subsidy greater than 0. I was probably intending to have some brackets there, some parentheses on lines 7 and 8, such that I kept the join, I kept the sales, I kept the California state, and I was only caring about a tax amount or a subsidy as a standalone condition. It's a really common mistake. Or perhaps this one. This SQL looks fine. I'm doing select star from the sales table where the region is in a list of promoted locations. So in this case, I'm only going to get some sales information where the region was in those regions I chose to do a Black Friday promotion. This looks fine, doesn't it? Until I describe the promoted locations table, and there's no region column in there. In the promoted locations table, it was called promoted regions. So surely this SQL won't run. It will, because what will happen is when this query runs, the subquery will say, you simply wanted the region from the sales table. This becomes an always true subquery as long as there's the existence of a row in the promoted locations table. Table aliases aren't just for making your code more documenting, they actually make your SQL code correct, and they can have a dramatic impact on performance. Thankfully, in Oracle Database 23AI, we actually have some tools now to actually help you catch these at the development phase rather than in production when someone phones you up with a performance problems. We have this new thing called SQL analysis in the optimizer. Let's do a simple example. I'll create a table called T1. It's just a copy of DBA objects, and I'll do the same thing as T2. They're two similar tables. Let's now do some bad SQL. So the first one I'll do here is I'll do a query between T1 and T2, and just like we saw in the slides, I've forgotten the join condition. The beauty now is with the SQL analysis facility is when I look at the execution plan, notice here in the notes column, we now get some feedback at development time. It says the query has a Cartesian product, which might not be what you wanted. We're trying to catch these errors now in development as opposed to after they become issues on your production server. Let's look at some other examples. I'm going to put an index on the created column on table T1. One of the common developer mistakes that we make is when we're trying to query date columns and eliminate the time component, then what will people do is they'll put a trunk around the sysdate variable, but also a trunk around the column itself. And as most of us know, if you put an expression around an index column, then you don't get to use the index. But now with SQL analysis in 23AI, we'll tell you. It says the following columns have predicates which preclude their use in indexes because you've got expressions around them. So it's important now that the database is trying to let you know that maybe there's a better way of writing that query. And let me give you one last example. I'll do an explain more T1 union T2. As you probably know, a union is quite an expensive operation because it gets the two result sets, and then to make sure there's no duplicates, it will actually sort the entire set. If we knew that T1 and T2 were already mutually exclusive, we wouldn't have to do that. And now SQL analysis tells us this. It says the query contains a union, which may be expensive. Consider using union all if duplicates are allowed or we know the results are mutually exclusive. So the cool thing now is, as opposed to you as a SQL tuner discovering these issues in production, with SQL analysis in 23AI, you'll be able to do this at development time and catch these common typos that we make in SQL before they become a problem. One final cool facility that's coming in 23AI I'd like to talk about is real-time SQL plan management. Now, rather than give you a full demo, I thought we'd simply walk through the history of SQL plan management, which probably explains how we ended up where we are with 23AI. In the past, as DBAs, we had a simple thing, which was what I call phone-based SQL plan management. What do I mean by that? Well, it's pretty simple. The phone would ring. It might be during the day, it might be 2 o'clock while you're asleep, but it's someone who is having a problem with their SQL statements. As a DBA, you were then called into action. You would then jump on the system. You would spend several hours digging around, trying to find the execution plan, what's gone wrong, had the stats changed, are we missing an index, has there been a recent deployment, etc. All the things that you would then spend your precious time and effort trying to work out what's going on and hopefully come up with a resolution to come up with an improved plan. Way back in Oracle 11G, we introduced what I would call the next level, which is manual SQL plan management. The phone still rings. You still get called out as a DBA. But rather than effectively starting with a blank slate, now you could go look at things like SQL tuning sets and your AWR reports, information that we had caught in the past, potentially about this SQL statement. You could then have a look and did this thing run better before? Maybe it's just the optimizer stats have changed, maybe something structural has changed, but what you can do is go find one of these plans that used to work fine and slot it into place. So you still got called out, but you could actually solve the problem without having to worry too much about going into root cause analysis. As I said, we're back on that triage concept. Just put a good plan back in place and we can go back to bed. In 12.2 and above, we introduced automatic SQL plan management. And the benefit there was the same process would occur, i.e., could we find a plan that was originally a better option for this SQL statement? And what would happen is, rather than the DBA being called out, you could actually do this now with a task. What would happen is a task would run each night and go look for SQLs that were running fine, that are now no longer running fine, and hopefully fix those problems without the DBA getting called out. This is an excellent option, and most people are using this today. The only downside is there's a latency. If this job is running once every day, then if you have a problem in the morning, it might be up to 24 hours before this task comes along and says, yes, you've had a bad SQL. I can solve that because I've seen a better instance of an execution plan in the past. So we wanted to minimize that latency, and that's what 23AI real-time SQL plan management is. What happens is you may still get occasional regression in a SQL statement. It may start to run slow, but literally the moment that SQL statement finishes, the database may detect that it has crossed some execution performance threshold and tag that such that the next time it gets parsed, we will do the work right there and then. So the next time that SQL is about to be executed, we say, last time I ran this, it ran badly. Let's go see if there's any information in our automated SQL tuning sets to indicate there's a better plan that we've seen in the past. If there is, we will at that moment slot that plan into place. The aim here is simple. Let's eliminate the phone call as well. So a user may get 1 or 2 performance degradations, but hopefully after that, the problems will go away as long as we've seen a good occurrence of that plan in the past. So my time is pretty much run out. In fact, I think I've gone over, but let's wrap things up. As I said, I'd like you to try, even though the session had some technical stuff in it, I'd like you to try forget about the technical. Remember that if you're tuning SQL and focusing solely on SQL, you're probably failing. You're doing it wrong. We want to focus on the user experience, which often will become a SQL tuning exercise, but not always the case. Remember, SQL tuning is triage, not the root cause. That's what we're trying to tackle here. If you can keep that mindset, I think you'll be very well prepared to tackle pretty much any SQL tuning challenges you have. With that in mind, hopefully you'll be out there toasting your customers' success, and they'll be patting you on the back for making their lives better, because ultimately SQL tuning is about making our customers more prosperous. Hope you enjoyed this session, and I'll hand back to the organizers.